But then you stand at the edge of a Roman harbor, still intact after 2 millennia. Waves that should have reduced it to rubble only seem to have made it stronger. Modern concrete crumbles within decades, yet this ancient wall endures. It stands there like a silent ghost of a forgotten science, defying the salt and the storms. You can almost feel the weight of the question pressing on the sea air. What did the Romans know that we have lost? Our own bridges crack, our highways split, our monuments weather into pale shadows. And still, this relic holds fast like a secret whispered in stone. The waves recede, leaving the structure not weakened but gleaming with a strange resilience. Here is the riddle that haunts the world of materials science. We had assumed our mastery of concrete was absolute and ever-improving. Yet the evidence sits beneath the water and stands beneath the Italian sky. The Pantheon's immense dome has hung over Rome for 19 centuries, with no steel reinforcement. It bears the marks of time, but not the mortal fractures that logic demands. Somewhere in the warm breeze off the Tyrrhenian Sea, the first trace of the answer stirs. It was not just any stone or any ash that built these wonders. They transported it along the coast from a place the locals called the Bay of Pozzuoli. When mixed with lime and seawater, it formed a reaction so violent it was said to boil. The resulting mortar did not just harden, it evolved into something akin to natural rock. This volcanic ash, rich in silica and alumina, was the beating heart of Roman concrete. Under the eye of an electron microscope, modern researchers finally glimpsed the truth. Tiny crystals had grown through the material like threads of living glass. They knitted the mixture together over centuries, filling cracks the moment they appeared. Where our concrete is inert and brittle, theirs was a quiet, ongoing alchemy. A microscopic forest of minerals kept weaving long after the builders had turned to dust. But the real key lay not just in the ash, but in a deliberate flaw they embedded. Small white chunks of lime, barely visible, sit scattered through the ancient matrix. For decades, archaeologists dismissed these as sloppy mixing or poor craftsmanship. You might look at a sample and see irregular white stones, like bones embedded in gray earth. In truth, these lime clasts were the concrete's silent guardians. When a crack forms, water seeps in and awakens the dormant lime. It dissolves and recrystallizes, sealing the wound before it can spread. The structure does not merely resist decay, it actively heals itself. A Roman seawall becomes a living entity in the slow dance of chemistry and time. Our modern steel-reinforced concrete is a betrayal of this ancient logic. Steel rusts, expands, and bursts the stone from within in a few short decades. The Romans used no steel, only the alchemy of ash, lime, and the relentless sea. Their secret was a dynamic harmony, not a static fortress. And yet, this knowledge slipped from human hands into the abyss of the early Middle Ages. The dark centuries buried not just empires, but the very recipes that held them up. Where archaeology records the fall, it also records a strange silence around their material science. Some say the secret was held only by a guild so protective that it died with its last member. Others whisper that the volcanic supply from Pozzuoli became too scarce or too dangerous to transport. A darker theory suggests the shift in building philosophy simply erased the old ways. Prestige turned toward cut stone and marble. The humble concrete was abandoned for cathedrals. Whatever the cause, the thread was severed, and a millennium of forgetting set in. Modern science, for all its power, found itself in the humbling position of an apprentice. Researchers began to recreate the ancient mix, standing in laboratories thick with the scent of wet ash. They measured precise ratios, mimicking the heat of a Roman kiln with modern furnaces. They poured their samples into molds and submerged them in brine, waiting for centuries in miniature. The results were astonishing. Their replicas grew stronger with every simulated year. It appeared the secret was not a single lost ingredient, but a process, a philosophy of integration. The Romans hot mixed their lime with volcanic ash at temperatures that seemed counterintuitive. This accelerated chemical bonds that modern cold mixing could never unlock. The mixture produced a heat of its own, a birth fire that echoed the volcano's forge. In the lab, small cracks began to heal within weeks, just as they did in the ruins at sea. The dream of self-healing concrete, long chased by engineers, had existed all along. Imagine a world where bridges seal their own fissures after a storm, where coastal defenses grow tougher under the assault of salt and tide, where the carbon footprint of construction collapses because structures last centuries, not decades. Standing on the shore of this possibility, you feel a shiver of awe and regret. We spent 100 years perfecting a material doomed to fail quickly. The ancient answer was sitting in plain sight, in the salt-crusted walls of an imperial port. One researcher described touching a Roman sample and feeling a kind of temporal vertigo. It was like placing your hand on a piece of technology from a more advanced civilization. Except that civilization was our own distant ancestor. The obsession took hold in labs from MIT to Naples, in minds that refuse to accept the loss. There are nights when a scientist leans over a petrographic microscope, lost in the crystal lattice. They chase the ghost of a recipe through chemical peaks and elemental maps. Each new paper published is both a revelation and a stark reminder of the void. How many other secrets, you wonder, lie buried under the ash of history's amnesia? The Antikythera mechanism, the flexibility of Damascus steel, the color of Maya blue. What we call progress is often just a long, painful reconnection with things we once knew. The Roman concrete mystery shakes the very foundation of our superiority. We assumed complexity moved in one direction, from primitive to advanced. But here is a primitive material that laughs at our advanced deterioration. The Roman harbor still stands, a mute philosopher in the water. Every wave that strikes it poses the same question that keeps material scientists awake. Is our civilization building for remembrance or for an accelerating cycle of ruin and repair? The crumbling infrastructure around us feels newly ominous under the shadow of this ancient success. Yet the rediscovery brings not only philosophy, but a tangible path forward. Pilot projects are now mixing volcanic ash into modern binders, hoping to scale the miracle. If we succeed, our cities might one day wear the quiet permanence of the Colosseum. But the deeper mystery will remain, lodged like a grain of sand in the oyster of history. It is not a mystery of chemistry alone, but of human memory and its catastrophic fragility. A society can know how to build empires and then forget how to mix the very mortar. The slow, hot breath of Vesuvius still carries the dust that built the eternal city. And we, with all our data, are only now learning to read the language it speaks. To stand before a Roman ruin is to stand before a mirror that reflects our own impermanence. The weathered stone does not just document their glory, it silently indicts our decay. Yet in that indictment lies a strange hope, a second chance handed down through the centuries. The ancient concrete whispers of resilience as a choice, not an accident. It tells you that time, given the right chemistry, can be an ally instead of an enemy. The harbor walls continue their slow alchemical breathing, and the tides keep testing their resolve. Each year, they grow a little denser, a little more woven into the planet's fabric. We arrived at this mystery arrogant, and we leave it humbled and curious. The final secret of Roman concrete may not be in the ash, but in the patience we have forgotten how to hold.